This is Kelly Hill, Executive Editor for RCR Wireless News. I'm here today with Adam Smith, who is Director of Marketing for LitePoint. How are you, Adam?
Doing great, Kelly. How are you doing?
Good, I'm doing good. If Mobile World Congress had happened, we'd probably be having this conversation in person, but since it hasn't, I'm excited to talk a little bit about what you guys would have been talking about if that show had happened. So why don't you walk us through what's going on at LitePoint?
Sure, yeah. We were bringing 4 products that we're very excited about that are really pertinent to what's going on in the wireless industry right now. So, of course, 5G is one of the hot topics going on. We have 2 products that are 5G centric, one focused at the millimeter wave bands, or the FR2. And we had a great demo that we are now showing virtually around how to make multi-device testing for millimeter wave economical. Okay. As we're here in 2020, what we're trying to do now is get beyond the can we do it in 5G and how do we scale. And so that's one of our focus for 2020 is scaling millimeter wave to high volume production. We were demonstrating our test equipment testing 4 devices in parallel to make economic testing for manufacturing.
And are there end user devices or equipment?
So in the near term, we were focused on the user equipment. So how do we get from just prototype volumes of these millimeter wave phones to shipping tens of millions of phones? And that's really where the focus is in that product at this point.
Okay. And what else was on the agenda?
So the little brother to that guy was our FR1, our sub 6 gigahertz 5G tester, and that's focused at same space, if you will. It's 5G phones, but it's focused at a totally different band. So focused on the bands that are at 6 gigahertz and below. And one thing that's interesting about that is just as we move forward from 2G, 3G, 4G now into a 5G reality, we're just pack rats of technology. So we're not throwing away any of the old stuff. We're adding new stuff, and so we're packing a lot of stuff into this little compact form factor of the phone. And so, this product is focused at testing all of those technologies efficiently, and again, scaling that to the multi-device for manufacturing.
Okay, great. And then Wi-Fi, I think, was also something that you guys had mentioned as coming up.
Yes, in fact, one thing we're extremely excited about this year is we're looking at a little over 1 gigahertz of new spectrum opening up in the unlicensed spectrum. And so we have a product that we've introduced that is focused on what's called Wi-Fi 6E, as it's been named by the Wi-Fi Alliance, which is deploying this 802.11ax technology to the unlicensed band that's roughly 6 gigahertz to 7.125 gigahertz. So we have a fully integrated solution that, again, we're pack rats of technology, is fully backwards compatible to previous generations of Wi-Fi and adds this new capability supporting this new band to enable devices. We're going to be seeing these devices probably mid to late this year, and people are developing as we speak. Okay,
so moving into this new spectrum pretty quickly then.
Yeah, it's a big change. I mean, the last time we saw this much spectrum open up in unlicensed band was about 20 years ago.
Oh wow. Okay, and there's a lot has changed since then. And
yes,
I imagine that will be a huge boon to Wi-Fi.
Yeah, it's a good opportunity. I mean, one of the challenges for Wi-Fi is it's the spectrum it operates in is relatively crowded now, and you can't just throw away all the old devices, and so you end up having a bunch of these collisions because Wi-Fi has been very much you take your turn type of technology. Things don't happen at the same time, and what the new band is opening up is enabling is people are going to play by a rule where we're only going to deploy the new technology in the 6 gigahertz band. So it's kind of having this pristine 8-lane highway to go drive cars down now, and so it's actually pretty exciting. People are going to definitely notice the performance difference as they go to the new Wi-Fi technology.
Okay. Did we cover everything? I feel like there's still some LitePoint products that we haven't touched on yet.
Yeah, actually, the one other thing it's now for something a little bit different is what we're seeing in the industry is a lot of these wireless technologies are adding almost like neurons and sensing capability to them. And so being able to detect relative position, relative direction, gesture sensing. And so one of the products that we were going to be demonstrating in Mobile World, and we're now demonstrating virtually, is a product focused on ultra wideband technology, which is a technology that's a little bit back from the dead. Once upon a time, it came out to be a high speed, in fact, was marketed as a wireless USB replacement. And the Wi-Fi has kind of evolved and taken up that space. But what ultra wideband is coming out to do now is more around how do I accurately detect position between two different devices. And it does that almost like a radar system using a methodology called time of flight. And what's interesting about that is that time is actually very hard to fake. So it's easy to intercept a signal and rebroadcast it, which is how, like for example, when you walk up to your car today and your little smart key says, "Oh, I'm next to the car," it's doing that basically by the signal strength. So it knows that if the signal's strong, you're standing next to it. But if a thief intercepts that signal, rebroadcasts it, they can fake that they're standing next to your car. And with this new technology, ultra wideband, one of the areas it's being explored is in the automotive industry. And it's a much more secure technology because it's really hard to fake time. The event either happened or it didn't, and you can't rebroadcast it and say it happened in the future.
Okay. And I should note for my audience that if you are used to thinking of ultra wideband in a Verizon context, because that is their marketing name for some of their 5G
True.
stuff, this is not that, this is a different ultra wideband, just to clarify. Adam, when you and I were talking earlier, you mentioned that there's sort of an overarching trend toward this ability to enable direction finding, to sense, gestures, to sense positioning. Can you talk a little bit about some of the other technologies that are moving in that direction as well?
Yeah, absolutely. Some technologies that have been around for a long time are now starting to add this capability. So, for example, Bluetooth. In one of the more recent SIG updates, they've enabled the ability to do what's called angle of arrival, angle of departure. And it's around this direction finding. So it can use the signal strength to find distance, and then it uses AOA and AOD to do direction. So Bluetooth is adding the ability to do this, and it'd be pretty useful for your average consumer mobile case where you're doing indoor navigation through a crowded space, airport, train station, that kind of thing. In addition, even Wi-Fi has added, there's a standard called 802.11az that is adding the ability to detect devices in its network. And it's doing this less for consumers interacting with it than for making networks more efficient. So if a network isn't being used, you put it into a low power mode. Or if a user is moving from one access point to another access point in an airport, for example, it handles the handoff more seamlessly. So really focused at power consumption and user experience. And then lastly, we're seeing some unlicensed 60 gigahertz radar applications. So that's used more for the gesture sensing. So if you wave your hand in front of a device, it goes to the next page, sort of thing. So many different technologies, all slightly different use cases. No two technologies are fighting for the same exact use case, which I like to see, because if everything is complementary, we can start to see more rapid adoption rather than wait to see which technology wins.
And then there's that whole pack rat phenomenon that you mentioned, where
absolutely, yeah, we add all of them to the technology or to the devices that we carry.
Great. So, question: as we start to see this new unlicensed spectrum come online, what does that pose in terms of deployment and/or technology challenges? I've had some folks bring up, the issues around potential interference, because you have 6 gigahertz being fairly close to existing 5 gigahertz operations. What are you seeing on that front? What are some of the challenges associated with bringing all of this new, a whole lot of new Wi-Fi unlicensed spectrum online?
Right. So on the deployment side, one of the challenges is just the fact that the people already live there. So you're trying to put an 8-lane highway in the middle of a residential neighborhood where somebody already lives there. So what the government's trying to do is gracefully move people out of that spectrum or come up with rules so that things can coexist. So for example, there's the 6 gigahertz band is broken up into 4 bands. And one of those bands is there's going to be some power restrictions. So you can't broadcast more than a certain amount of power, likely to be used for indoor usage. And so what this really means is that as you deploy devices, whether it's a smartphone or whether it's an access point or whether it's whatever, there's going to be some geographical rules. And so when the device comes on and says hello, it's going to have to check, where am I in the world? Am I allowed to use this band? And there'll be certain lookup tables that are required in order to figure out how do I play by the rules and make sure I don't interfere with other people. So there is a little bit of complexity to that. It's primarily mostly on the getting everybody to agree to the same rules and then putting that into the firmware of the products. On the technology side, we've just been living in such a sub-6 gigahertz world for so long with consumer technologies. We've kind of got this artificial barrier at 6.0 gigahertz when it comes to equipment. And this goes from everything from component selection. So I'm speaking from a test-centric point of view, I look at things like switches, amplifiers, filters, and 6.0 gigahertz has been such a magic number that we've all circled around. Getting above 6 gigahertz, you're into fairly low volume, exotic, expensive. And so the challenge moving forward is going to be, how do we make these new bands just as economical as the old band? And so what we've done is we've re-architected our product from the ground up with this thinking in mind, so that we can seamlessly get people from these old legacy technologies to the new technology. And we do this in a 100% backwards compatible method. It's fully integrated.
Okay. Now, it's funny because this whole idea of, a device checking in and seeing where it's allowed to operate and what it's allowed to, and what spectrum it's allowed to operate on, sounds a lot like CBRS. We do have some midband spectrum coming online, and I'm wondering if you have any sort of reflections on, on the impacts that we might see from that. We've got obviously the priority access license auction coming up. We've also got the C-band that is, I guess, supposed to make it to market this year if the FCC has its way. Any thoughts on, on the need for and/or desire for mid-band spectrum, particularly for 5G?
Yeah, absolutely. I'm personally very excited about the C-band auction that should happen later this year. I see it as a necessary part of rolling out 5G. We've done a really good job from a North American perspective of rolling out millimeter wave and making it available. And so the spectrum auctions that are going on, there's actually a current auction going on for 47 gigahertz, so yet another millimeter wave band. But coming out with a successful rollout of 5G that hits everyone, not just some small deployments in some densely populated cities, we're really going to need this mid-band spectrum, or the C-band. And I kind of call it the Goldilocks of spectrum. The LTE, like the 600, 700 megahertz was like the gold standard for LTE because it went a long distance, and there was enough spectrum. But it's not so useful for 5G because you just don't have the bandwidth there. So low band is okay, it's great coverage, but not enough bandwidth. The high band, the millimeter wave, it's incredible bandwidth, but the coverage is really challenging. So you have to deploy very densely populated cells. In the middle here, you got the mid-band spectrum, which is, again, kind of this Goldilocks zone. You get more bandwidth, which gives you the better data throughput, gives you more user capacity, and 5G makes more spectral efficiency use of that spectrum. Plus, it has much better coverage than when compared to the high band. So you can kind of get this decent coverage and decent bandwidth availability. Now, that being said, not one of these is the winner. We need all of these to play together. So we need good coverage, we need high throughput, and we need kind of this middle ground. And the whole point of 5G is we roll out this kind of almost a general purpose network for these new use cases to take advantage of it. And if a use case needs the super high bandwidth, a millimeter wave, we can put a deployment around that. If it's a more general population, I got to cover a town, the mid-band spectrum does a good job of that. So it takes all of these tools in the toolbox to come out with a successful 5G rollout.
Okay. So is there anything we haven't touched on at this point in terms of, what you guys are seeing in the market and how it's reflected in the LitePoint portfolio?
Maybe just a final comment around this mid-band spectrum.
Yeah.
If you've been following any of the analyst predictions about numbers of units, I mean, notwithstanding the current COVID-19 virus situation we're in right now, but we are expecting this to be a massive rollout in smartphones and 5G, and it's going to be primarily driven in China region. And one of the reasons for that is it's the mid-band spectrum is widely available in China. So their emphasis has really been around mid-band and not so much in the millimeter wave. And they're, not only is the government incentivizing customers to move to this by subsidizing phones and things like that, but it's really helping to drive the rapid deployment of 5G technology. And we're seeing that in China first because the deployment in mid-band is much more straightforward than it is in the millimeter wave. But we'll see this coming online, hopefully next year here in the US as well. So we are seeing a rapid adoption of 5G, but it's probably going to be in Asia Pacific this year in the extremely large numbers. And then we'll see the growth take on pretty significantly as we start deploying these bands here in the US.
Oh, wow. Okay, great. Well, Adam, thanks so much for the time today. I really appreciate being able to catch up with you folks, and we'll be keeping an eye on LitePoint in 2020.
Okay, thank you, Kelly.